Today the learning goal is to compare linear functions through graphs, tables, and equations. The work is in IXL L13. As a review, the same linear equation can be represented in three ways: a graph, a table, and an equation. As you know, the graph has an XY axis. A table can be XY values, or as you've learned, they can be functions with Y values, and the equation is in the form y equals mx plus b. Let's look at the slope and how we can find it through a graph, a table, and an equation. So there's nothing new here. This is just a review of what you learned before. When you look at a graph, you know that the slope can be found using rise divided by run. So you pick 2 points on the chart and calculate the rise divided by run. Also, you can be given 2 points on a line like 2, 1 and 3, 3, and you can use the equation for slope to calculate slope. And the equation for slope is y2 minus y1 divided by x2 minus x1. And when you calculate slope in that way, you can see you would get the same answer, which is 2. You can also calculate slope in a table. So in the table, we could look at the values here, and then we can use the equation y2 minus y1 divided by x2 minus x1 to find that the slope is 2. It's exactly the same thing that you see over here. It's just in a different way. And then in equation format, you know that the number in front of the x here is the slope. So we can use different methods to find that the slope is 2. We can use points on a graph. We can do the equation y2 minus y1. We can find slope from a table, and we can find slope in the equation. In all cases, the slope is 2. What about y-intercept? We can also find y-intercept in a graph, table, or equation. When we look at a graph, we know that the y-intercept is where the line crosses the y-axis, or where the function crosses the y-axis. In a table format, we can look at where x is 0, and we can see that the y-intercept is -3. Or in the equation, we know that the very last variable is also the y-intercept. So in these three cases, you can see that the slope is -3, either by looking at a graph, a table, or an equation. So we're going to use that information to solve some problems in IXL. So let's take a look at function A and function B. So function A is in linear form, and it asks us to find the slope of function A. So we know the slope of function A is this number in front of the x. So the slope for function A is 2. Well, they also asked us to find the slope for function B. So what is the slope for function B? There's a lot of ways we can do it, but let's look at 2 points where the line crosses the grid lines exactly, and we can see the rise is 1, 2, 3, and the run is 1. So slope is rise divided by run, which is 3 over 1, or 3. Okay, so we can see the slope in function A is 2, and the slope in function B is 3. So let's take a look at the question. Which statement is true? The slope of function A is greater than the slope of function B. That's not correct. And the next line says the slope of function A is less than the slope of function B. That's correct. So that's the answer you would choose. Okay, let's take a look at another example. here it says function A and function B are linear functions, and we're given function A here as a graph and function B here as an equation. And they're asking us about the y-intercept in function A and function B. So we're going to compare the y-intercept for function A and function B. So first of all, what is the y-intercept for function A? The y-intercept is where the function crosses the y-axis, or the y-intercept in this case is 2. If we look at the equation, the y-intercept is the last value. So the y-intercept here is -5. Okay, so now that we know the values of the y-intercept, we can compare. Look at the first statement. It says the y-intercept of function A is greater than the y-intercept of function B. So that's true because 2 is greater than -5. And I always read the second question just to make sure. It says the y-intercept of function A is less than the y-intercept of function B, and that's incorrect. So we know that the first response is correct. Let's take a look at one more example. It tells us function A and B are linear functions. So function A is represented as a graph, and function B is represented as an equation. So which statement is true? The y value of function A and the y value of function of B. So what that means is we have to solve this equation when x is -1. So let's take a look. When x is -1, which is here, the y value would be -2. Okay, so I'm gonna erase that so you can see a little better. So the y value is -1, and if you go down and across, you can see that the value for the y function would be -2 when x is -1. Okay, now in equation form, we want to know what the y is when x is -1. So all we do is y equals 5 times -1. We just put -1 where the x is, minus 2, and you use your order of operations to solve. So y equals -5 minus 2, y equals -7. So now we can compare, because we know in the equation y equals -7, and in the graph y equals -2. So let's take a closer look at the question. The y value of function A when x is -1 is greater. So is -2 greater than -7? Yes. And let's look at the next statement. The y value of A when x is -1 is less than B. No, that's incorrect, because -2 is greater than -7. Okay, so in summary, linear functions can be shown in graphs, tables, and equations. And what that means is slope and the y-intercept can be shown in graphs, tables, and equations, and you can compare them. So the work for today is an IXL L13.